Alright, let's take a look at this problem. Search suggestion system. Given an array of strings, products, and strings search word, we want to design a system that suggests at most 3 product names from products after each character of search is typed. So it reminds me the try data structure. Suggested products should have common prefix with the search word. Common prefix with search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Right. Return list of lists suggesting products after character of each character of that. Okay. So I have these. Okay. After each character of. Alright. So I'll just return that. That's alright. Okay. So it is 99% a try implementation. So search suggestion system. Alright. So how do we do this? So in a try, we have to mark the character to. Okay. For this, I need a try. Every time I click, I just go one item below, and then I just search there and return the possible paths. So I can also have a prefix array, but using a try sounds better, nicer. So I have an implementation, not implementation, but in my notes, I want to check the try implementation. So normally, like we need is word, and then we need possible word is word, and then insert. When we are inserting, we just create a new list. Okay, I found it, but there is a problem there. If you are looking for, I think try might not be the solution here, because if we have, let's see. Okay. But how do we know if we have a try, if we have M, right? It starts with M. In that case, maybe we store number of possible words below that, but that doesn't make sense. I'm actually not sure about this, because I know that like in try, if I have try, maybe first I sort them in lexicographically minimum. Yeah, like lexicographically, I have my minimums there, and then for every one of them, if I have suffix 3, create suffix 3 for every different character, or every prefix. Actually, for every prefix, I will have my possible answers. I think that works, but the complexity is pretty high. Yeah. But I think that works. So if I like products, let's sort, and then so I create Hashtable dictionary. I'm gonna call it like this. While not while, but for every product in products, I take that word from that, and then for each one of them. So for each one, for every length of it, for every in range length of product, this, which will, by the way, start from 1 till the end. And then for that, like, I will have dictionary. What is that? P from start to I. I'll just create it. I can have this default text list, and here that append the index, which is I mean, actually it doesn't matter, right? I can just put P there because it will always same complexity. So if I do this, then I just create it, and then here if I just print the dictionary, and I just return this, I'll have something very long for M. I have this, Mo, I have those, and it goes on like that. And so here for every character in search word, if so I just return back like for every one of them. So I will have my results here. So here are results. I'll have this results that append the first 3 of them. So C, so dictionary C, and from that I'll just return until first 3 of them. And here I just want to return the results. Yeah. So here I just return first 3 of them. And the second one, I just search, just all of them. Just return all of them. Second one, you just return in search word every character. But yeah, this is actually wrong. But so for every I in range length search word, and here instead of this I'll have search words from 0 to I. It will start from 0, this will start from 1 now, and it goes on like that. And I will have my monitor like that, and like that. So this is actually the same thing if you I have one more. This should be from 0. Maybe. Actually, no. 1, 2, 3. I'm missing one because, yeah, I should have a +1 here. Just wait a second if I remove this, but it doesn't make sense. I want to start from the first and second one. Actually, when it is 1, I just have it like that. Oh, okay, I should have +1 here. No. So I have 0, 1, 2, 3. Okay, if I have +1 here, I should remove this. So I start from 0 to 0th index until the end. And I won't take the last one. No, I will add the last one. I want the last one. But if I remove this. So okay, I start from the first. Actually, let's print that. Why do I even bother? Okay, so I'm missing the last one. Like here. Okay. Like that. And must pass. No, I don't want this. Wait, I want that. Mouse 1, 2, 3, 4, 5, 6. Oh, I don't want the first one. Okay, actually I was right, but I had some extra those in those places. So I have mouse pad. Wait, this is a wrong print dictionary. When I have mouse, wait, this should not be the case. Mouse pad, mouse. Actually, that's correct. Start from 1. I mean, I was right, but so there is a problem here. So when it is mouse, I'm not adding it into mousepad. So it's pretty weird. I also want this too, right? I want the mousepad too here, like this, because it is in it. So I'm not, appending putting the last one. Okay, so what's the complexity here? By the way, we can, put this. Let's test these. I think they will all work. But so what is the complexity here for every word, every character? Let's say that they're all same. In the worst case scenario, you will have n times the length of it. So n times k. K is the longest word. So time is of n times k, and like p length products, k longest word. Okay, let's see actually if this is the optimum solution. I think there's a better way to do it. It says binary search. Simple try implementation also. What is the prefix tree's complexity? It says N again for sorting. Oh, I forgot about sorting. It is n log again plus p times k. Let's see. So for sorting and quick sort, time for each query is like that, so it doesn't matter. So at the end we will have space will be the query, length of query. Is using some sort of built-in things. I'm not sure. Yeah, I'll check this tree implementation maybe, but this works, and I think so. Oh, by the way, spaces, of course, of n times k to the power of actually it's n times k for every one of them I have. That's okay. I'll be looking at the try, maybe implement that. For now, I'll just stop it. If not, I will I will pause it and then maybe continue with it. All right, so I implemented the tree implementation. So what I did was I created a try node, and of course this is a default. We create this, and we also need suggestions for every character, every node in the try. And the insert is pretty simple. You first get the first node, and then from there you just create another node, and then it goes on like that for every character in the word. And while doing that, we also append the current node to the suggestions. So because of this, the space complexity is the longest word's length times every word. So here, like this. So this is the number of characters in the longest product, and k is 3. So this is for suggestion, how many suggestion you want. But for that, by the way, here, like for this code, this k is actually the number of characters, like number of words, every possible word, because I get it like this, first three suggestions like this, but I could also do it in a different way. Like if actually, yeah, I can do it here like this. So it will be actually of n, which will be like, I'm gonna put it here, 3 there, but here it should be like this. So if node that's suggestions, of course length is less than 3, do this. Okay, so this should also work. So this will be just of n times m, length of the word times the total number of products, and the time is actually, this is also of n times m. I think this is wrong here, because for every word, for every product we go and insert, and for every one of them we just create that and the suggestions in every try node. And we also append if it is necessary. But of course it can be in there, but in the worst case complexity, I think this should be all n times n. By the way, what is the like try complexity? I'm actually curious. This is all L W times L lengths and numbers. Yeah. Okay. So yeah, I think this is correct. So this will be 3. But yeah, I'm gonna hold the 3 here. So output is just of k, because we just have to of s, because we just, for every one of them, like every character, we go down for that many number of characters, And of course, the space is s times k. K is the length of the maximum characters in suggestions. So we return it like that. So this is why we have this. But I think this is much simpler. By the way, I forgot to tell, but here again we have to sort it. So which is n log n. So I think it is pretty similar to my solution, which is much simpler like this without any try implementation. But this also works. I wanted to implement this, so just to practice. So all right, so that was it. And here we insert it, we call it for everything, and then here I just don't have to return that. Just it's okay to do it like this. All right, so that was it.